This is part 2 of Lesson 8 of Unit 6, Advanced Integration Techniques. In this video, we're going to be talking about how to use partial fractions to integrate rational expressions. Okay, the type of rational expressions we're talking about are ones where they are proper rational expressions, and by that means that the degree of the numerator is less than the degree of the denominator. What we saw in a previous lesson was that if we have an improper rational expression, we can use long division or completing the square to integrate those types of fractions. So this method is for the type of fraction that we can decompose into linear factors, such as this. So we can take 2 over x squared minus 1 and rewrite it as negative 1 over x plus 1 plus 1 over x minus 1. So the right side of the equation is called the partial fraction decomposition, and that is exactly what we're going to do. So how this works is the idea that each distinct factor, ax plus b, is the sum of partial fractions and includes a term in the form of a over ax plus b. So our job is to find these coefficients in the numerators that will allow us to integrate each of these nice linear rational expressions, so to speak. And I just want to make a note, you are only going to have ones where the denominators contain non-repeating linear factors. So in other words, you're not going to have like x minus 1 squared in the denominator. Okay, they're going to be distinct linear factors, such as x squared minus 1, or it might be a quadratic, such as this one that you can factor that is not a perfect square trinomial. Okay, so let's look at some of these examples. So this is how we go through this process. We need to split our denominator of the integrand so that each can be integrated separately. So we need to find, as I said, the a's and b's, the coefficients that go with them. So here's how we go through that. So first thing we need to do is we need to factor the denominator. Okay, so we're going to write this as, and we're going to ignore the integration right now. So we have 1 over x minus 2 times x plus 2. And so we can write this as a over, and it really doesn't matter what order you write these in, because it'll just work out in the end that they'll have the right coefficients and the correct signs. Okay, so from there then, you can add this, and by doing that you have a times x minus 2 plus b times x plus 2, and this is all over x plus 2 times x minus 2. All right, now here's what we know, is that expression in the numerator has to equal the 1, because now the denominators are the same. So that's what we're going to do. We're going to take 1 and set that equal to, and I'm going to expand this, ax minus a2 plus bx plus b2. And then to combine the x's here, you really have x's a plus b, and then we have the other terms. Then we have the minus, if we want we can factor out a 2, then we have b minus a. Alright, so here's what we know, is that here we have an x term, but over here we don't. So that tells me that a plus b has to equal 0, or in other words, a is going to equal negative b. So then I can use that in this expression to solve, because 2 times b minus a has to equal 1. So if a is negative b, so that means 2 times b plus b has to equal 1, then I'm going to have here 4b equals 1, so b is going to equal 1/4. So that means that a is going to equal negative 1/4. So now the integration becomes super, super simple. So now this is what I have. I have the integral of a, which is negative 1/4, of 1 over x plus 2 dx, plus 1/4 times the integral of 1 over x minus 2 dx. And now these are just natural logs. So I have negative 1/4 ln of x plus 2 plus 1/4 ln of x minus 2, and then my plus c. The most work comes in finding a and b. So I'm going to do one more using the proper algebra, and then for the next two examples, C and D, I'm going to show you a shortcut of how to find your coefficients, especially if you have more than two, because then you would need three equations, and it gets a little involved. So this will be a lot faster once I show you the shortcut, but I want to make sure that we have the proper algebra down going forward. Okay, so for the next one, we're going to write x, make this look a little nicer, x minus 11 over, and when I factor the denominator, I get x minus 5 times x minus 2. And so I'm going to separate that, and I get a over x minus 5 plus b over x minus 2. And so I'm going to go through the same process that I did before and find my a and b. So what I have here then is that I have a times x minus 2 plus b times x minus 5, and that's all over x minus 5 times x minus 2. So now I have x minus 11 is going to just equal the numerator, and I have ax minus 2a, plus bx minus 5b. Now in this case, when I put my like terms together, what I'm going to see is that when I factor an x out, I have a plus b, and then I also have negative 2a minus 5b, and I can't really factor anything out of that. So now in this case, I do have an x term, and its coefficient is 1. So that means that this is the same coefficient, so that has to equal 1. So a plus b has to equal 1. So that means that I can solve for a, which is b minus 1. And now I'm going to substitute it in the other part, and I know that negative 2a minus 5b has to equal negative 11. So if I substitute for a, I have negative 2 times b minus 1 minus 5b equals negative 11. So simplifying this expression, I have okay, before we go on here, I realize I just made a little mistake. This should be 1 minus b. So when I substitute here, this will be 1 minus b. I was realizing as I was doing it that I was having a sign mistake, and I couldn't figure out where it came from. Okay, because when you solve this, you're going to subtract the b. Okay, so now when I distribute, what I have here is, and simplify, I get negative 2 minus 2b minus 3b equals negative 11. So I get b is equal to 3. So that means a is going to equal negative 2. So now I can do my integration. So I'm going to have negative 2 over x minus 5 dx plus the integral of 3 over x minus 2 dx. You want to be careful you put the right letters back with the right linear factor, or else you won't get the correct answer. So then this becomes negative 2 ln of x minus 5 plus 3 times ln of x minus 2 plus c. Okay, now that's a lot of work. Look at all this work here. All of this is just work to find two coefficients. So is there an easier way to do that? And the answer is, of course there is. So what is that easier way? Let's look at these last two, especially d, because d is going to have three linear factors since it is a cubic function. Okay, so let's rewrite letter C. The method hasn't changed, just how we find our coefficients is going to change. So we have 3x plus 6 over x times x plus 3. So when we decompose this, what we're going to get is we're going to get an a over x plus a b over x plus 3. So here's the shortcut. The shortcut is this. If we let each of the x's in the denominator be a value that would make that factor 0, we simplify the whole process. So here's how you do this with a shortcut. I'll just go through it. So as we can see here, x, a is sitting above an x by itself. So how would I make that x go away? And I know it's in the denominator, but just suspend the idea that it is undefined. So the idea is if I let x equals 0 in the original function, what I get is that I get 3 times 0 plus 6 over 0 plus 3. So I'm just going to ignore that for now. Like I said, I'm suspending the idea of a well-defined domain and all of that. And so what I get here when I simplify this is I get 6 over 3. So that equals 2, so that's my a. Okay? Then I'm going to do the same thing with the b fraction. If I wanted that to go away, I would let x equal negative 3. So my original fraction, I'm just going to ignore that x plus 3 term. So I am going to have 3 times negative 3 plus 6 over negative 3. So I'm keeping the x, losing that term. So when I simplify this, the top becomes negative 3 over negative 3. So that is 1, and that's my b. And that's a lot shorter. It's kind of a shortcut. Okay, so that means now that my integration looks like this. I have the integral of 2 over x dx plus 1 over x plus 3 dx. And I forgot my integral there. And so this becomes 2 ln of x plus ln of x plus 3 plus c. Okay, so let's do that again. And you can see, especially in the next one, how it's going to save so much time instead of having to solve a system of 3 equations. So we're going to rewrite our fraction as x times x plus 2 times x minus 2. Because when you factor out the x up there, you get x squared minus 4. Let me just write that here so you can see it. And x squared minus 4 factors into x plus 2 times x minus 2. Okay, so expanding this then into our partial fraction decomposition, we're going to have a over x plus b over x minus 2. And again, the order doesn't matter, that's why I'm switching them around to show you that, plus c over x plus 2. Just remember when you go to do the integration that you put the right coefficient again with the right factor. All right, so if I let x equal 0 in the original fraction, I'm going to have 0 plus 0 plus 12. So I am going to have 12 over, and I remember I just ignore the x, so I have 2 times negative 2, and so I get 12 over negative 4, which is negative 3, and that's my A. And then for B, I'm using x minus 2, so I let x equal 2, and then what I'm going to get is I'm going to get 2 squared, so I get 4 plus 20 plus 12, and when I add that together I'll get 40, and in the bottom now this term is gone, so I have 4 times 2, which is going to be 8, so I have 40 over 8, which is 5, so that's my B. And then finally for C, I'm going to let x equal negative 2, so I'm going to ignore this term in the bottom right here. This term gets ignored this time, and when I do this I'm going to put negative 2 in, so I get 4 minus 20 plus 12, and in the bottom I'm going to have negative 2 times negative 4. So in the top I get negative 8, and in the bottom I get 8. Do I get negative 8? So I have 16 minus 20, get negative 4. Okay, it helps if I can do basic multiplication. That should be negative 24 plus 12. So I get, so that'll be negative 20, that would be negative 8 over 8. So I get negative 1, which is my C. And then from there, I just have to do the integration. So moving this up a little. So now I'm going to integrate negative 3 over x, over x dx plus 5 over x minus 2 dx minus dx over x plus 2. And so when I integrate that, I get negative 3 ln of x plus 5 ln of x minus 2 minus ln of x plus 2. I don't know if you guys can see that because my screen, that was the edge of my screen. And then I have my plus c. So that's integration by partial fractions. So that's the end of lesson 8. And we'll go over this more in class, our next class. So if you have any questions, please hold them till then.